All right, everybody, Professor Bryant back. Another installment of Workout Wednesday. Today we're going to be working on some problems that are related to Chapter 4. So we're talking about solutions, concentration, and solution stoichiometry. These two examples are going to be formation and making of a solution. So if you go into D2L, this is underneath the PDF called Solutions Worksheet. We're going to go down to the bottom and look at a couple of these examples in the lab calculation review problems. So first example we're going to have is number 2. We're going to do number 2 and 3 in this video. Okay, so number 2 says, what is the molarity of strontium ions in a 0.421 molar solution of strontium phosphate? What is the molarity of phosphate ions in this solution? So this is an example very similar to what you're going to see on the homework and also potential types of questions in the assessment. So what I suggest, and again, another example where stoichiometry and nomenclature is going to be involved, or just being able to determine the ratio in a chemical compound. So strontium phosphate, this is 2A, strontium is 2 plus, so we got SR3 PO4 2. This is strontium phosphate. It is aqueous. Based on solubility rules, you can verify that. Okay, so there we have the chemical formula. Got to be able to convert the name to the chemical formula. So they want to know what is the molarity of strontium ions. So if we have a molarity of 0.421 moles of strontium phosphate per 1 liter, then we can use dimensional analysis to convert that to strontium. So for every 1 mole of strontium phosphate, there are 3 moles of strontium 2 plus ion. So effectively, we're dealing with a situation where we have 0.421 times 3, 1.26 molar of strontium. So we needed the formula to then determine how many strontium ions per 1 mole based on the molarity of solution. And then they want to know molarity of phosphate. So what we can do is we can reproduce the same dimensional analysis, and we see that there's 2 moles of phosphate ion, 3 minus, per 1 mole strontium 3 phosphate. So 0.842 molar phosphate. Remember, units are always going to be important when you're dealing with anything involving aqueous chemistry. All right, so let's take a look at number 3. So number 3 asks us how many milliliters of lithium chromate, a 5 molar solution of lithium chromate, are needed to prepare 3 liters of a 0.25 molar lithium chromate solution. So this is a dilution. We should be able to recognize that. And then they ask us how much water is added. So again, the making of a solution from a stock, which is what this 5 molar lithium chromate is very standard. You have to be able to do this calculation. So we are utilizing M1V1 equals M2V2, where we know M2 and V2, right? We know M1 is equal to 5.00 molar. We know V1 is what we're looking for. And we know M2 is equal to 0.250 molar. And V2 is equal to 3 liters. Okay, so all we're doing here really is we're solving for V1. V1 is equal to M2 V2 over M1, which is equal to 0.250 molar times 3.00 liters all over 5.00 molar. Notice we're left with the units of interest, which are liters, and so 0.25 times 3 divided by 5, 0.15 liters. Now, part B asks us how much water do we need to add to the new solution, the diluted solution. Well, we need 3 liters. So we have to take 3 liters minus the amount that we're using from our stock, which then gives us 2.85 liters of water. Excuse me, sorry, didn't have that down there. So we got M1 V1. We use that to calculate V1, which is the amount needed. V1 is the amount needed from the stock. We calculate the amount needed. We place this much into whatever volumetric glassware we're using, and then we add approximately 2.85 liters of water. All right, and let's actually do one more problem. Let's do number 4. And what number 4 is a calculation of the molarity of a solution, which is a very straightforward problem, but we're going to see problems like this as well on the assessment. Number 4 asks us to calculate the molarity of a solution that we prepared using a particular amount of a salt, in this case 35.8 grams of magnesium perchlorate, and in enough water to give us a solution of 275 milliliters. Okay, so how do we approach that? Well, first off, we need to be able to go from the name to the formula. Perchlorate is ClO4 minus, so magnesium perchlorate is ClO4 2. All right, they tell us we have 35.8 grams. Again, we always need to convert to moles. Now, the volume that they give us is 275 milliliters, or 0.275 liters. So if we have grams, for every 1 mole of magnesium perchlorate, we have so many grams of magnesium perchlorate. And we calculate the molar mass using our periodic table. 24.3 plus 35.45 plus 16 times 4. Looks like 123.75 is our molar mass. Excuse me, that's incorrect. It should be 223.2. Sorry. Again, make sure that you're double checking always your molar masses. Always good to double check these. Now we know moles of our solute. To get molarity, we need volume of solution, so we can put in liters here, 275 liters, and that will give us our answer. 35.8 divided by 223.2 times 0.275, and it should be 0.583 molar of our magnesium perchlorate. So there are the 3 examples from the worksheet. What is the molarity of ions in solution? What is a dilution and how do you achieve it? And then this last one is, what is the molarity of a solution that you prepare from a particular mass? All right, again, if you have any questions, feel free to send me an email.